Hello and welcome to this video walkthrough on how to work with Jupyter Notebook. In this video, we will be exploring a Jupyter Notebook that contains code for working with weather data. Specifically, we will be using the pandas and NumPy libraries to create a data frame, perform various operations on the data frame, and export the results. So, let's get started. Hello and welcome back. In this cell, we are importing two libraries, pandas and NumPy. These libraries are commonly used in data science and analysis to help manipulate and work with data. By importing them, we can use their functions and methods in our code. That's it for this cell. In the next cell, we will be creating a data frame using pandas and performing some operations on it. Stay tuned. Welcome back. In this cell, we are defining a function called header that takes in a message as an argument and prints it out with a line of dashes above and below it. This function will be useful for displaying messages in a clear and organized way. Next, we are creating a data frame using pandas. This data frame contains weather data for each month of the year, including the average high and low temperatures, record high and low temperatures, and average precipitation. We are assigning this data frame to the variable df. Finally, we are using the to_CSV method to export the data frame to a CSV file called foo.csv. This will allow us to save and share the data with others. That's it for this cell. In the next cell, we will be using some pandas methods to explore and manipulate the data frame we just created. Stay tuned. Welcome back. In this cell, we are using two pandas methods to explore our data frame. The first method is df.head, which displays the first 5 rows of our data frame. The second method is df.tail, which displays the last 5 rows of our data frame. By using these methods, we can quickly get a sense of what our data looks like and check if it was imported correctly. In this case, we can see that our data frame contains weather data for each month of the year, including the average high and low temperatures, record high and low temperatures, and average precipitation. That's it for this cell. In the next cell, we will be using another pandas method to explore the data types of our data frame. Stay tuned. Welcome back. In this cell, we are using a function called header to print a message with a line of dashes above and below it. This function will help us display messages in a clear and organized way. Next, we are using the dtypes method from pandas to explore the data types of our data frame. This method tells us the data type of each column in our data frame. In this case, we can see that the month column is of type object, which means it contains strings, while the other columns are of type int64 or float64, which means they contain numerical data. That's it for this cell. In the next cell, we will be using another pandas method to explore the index of our data frame. Stay tuned. In this cell, we are using the header function to display a clear message. We then use the index method on our data frame df to display the index values. The output shows that our index is an int64 index with values ranging from 0 to 11. In the next cell, we will be exploring the columns of our data frame using the columns method. In this cell, we are using the header function to display a clear message. We then use the columns method on our data frame df to display the column names. The output shows that our data frame has 6 columns: month, average_high, average_low, record_high, record_low, and average_precipitation. In the next cell, we will be exploring the values of our data frame using the values method. In this cell, we are using the header function to display a clear message. We then use the values method on our data frame df to display the values of our data. The output shows the values of our data frame, which includes the average high and low temperatures, record high and low temperatures, and average precipitation for each month of the year. In the next cell, we will be exploring some statistical information about our data using the describe method. In this cell, we are using the describe method on our data frame df to get some statistical information about our data. We use the header function to display a clear message. The output shows the count, mean, standard deviation, minimum, maximum, and quartile values for each column in our data frame. This information can help us understand the distribution of our data and identify any outliers. In the next cell, we will be sorting our data frame by the record_high column. In this cell, we are using the header function to display a clear message. We then use the sort_values method on our data frame df to sort the data by the record_high column in ascending order. The output shows the sorted data frame with the months in order from January to December, with their corresponding average high and low temperatures, record high and low temperatures, and average precipitation. In the next cell, we will be exploring the average_low column of our data frame. In this cell, we are accessing the average_low column of our data frame using the dot notation. This will return a series containing the average low temperatures for each month. We can see that the series is of type integer and has 12 values, one for each month. In the next cell, we will explore another way of accessing this column using bracket notation. In this cell, we are accessing the average_low column of our data frame using bracket notation. This will return a series containing the average low temperatures for each month. The output shows the values for each month, starting with January and ending with December. We can see that the series is of type integer and has 12 values, one for each month. In the next cell, we will explore another way of accessing a subset of our data frame using bracket notation. In this cell, we are using bracket notation to access a subset of our data frame. The code df2 to 4 returns a new data frame containing rows 2 and 3, which correspond to the months of March and April. The output shows the average high and low temperatures, record high and low temperatures, and average precipitation for these 2 months. In the next cell, we will explore another way of accessing specific columns of our data frame using bracket notation. In this cell, we are using bracket notation to access specific columns of our data frame. The code df average_low, average_high, record_high returns a new data frame containing only the columns average_low, average_high, and record_high. The output shows the values for each month in these 3 columns. In the next cell, we will explore another way of accessing a subset of our data frame using the ILIC method. In this cell, we are using the ILIC method to access a subset of our data frame. The code df.ilic5 to 8, 0, 3 returns a new data frame containing rows 5, 6, and 7, and only the columns month and record_high. The output shows the values for these 3 rows in these 2 columns. This method uses array-like indexing, where we specify the row and column indices we want to access. In the next cell, we will explore another way of accessing a subset of our data frame using the lock method. In this cell, we are using the lock method to access a subset of our data frame. We are selecting rows 5 to 8 and columns average_low, average_high, and record_high. The output shows the values for these columns for the selected rows. This is another way of accessing a specific subset of our data frame. In the next cell, we will see how to access a single row using the lock method. In this cell, we are using the lock method to access a specific subset of our data frame. We are selecting rows 9 and columns average_low, average_high, and record_high. The output shows the values for these columns for row 9. This is another way of accessing a specific subset of our data frame. In the next cell, we will see how to access a range of rows and columns using the ILIC method. In this cell, we are using the ILIC method to access a specific subset of our data frame. We are selecting rows 3 to 4 and columns 0 and 3. The output shows the values for these columns for the selected rows, which are the month and the record high temperature. This is another way of accessing a specific subset of our data frame. In the next cell, we will see how to access a range of rows and columns using the ILIC method. In this cell, we will continue exploring how to access specific subsets of our data frame using the lock method. Specifically, we will select rows based on a condition. This is useful when we want to filter our data based on certain criteria. We will use the lock method to select all rows where the record_high temperature is greater than 90 degrees. Stay tuned for the next cell to see the output of this operation. And that concludes our walkthrough on working with weather data in Jupyter Notebook. We covered a lot of ground, from importing libraries to accessing specific subsets of our data frame using various methods. By using pandas methods, we were able to explore our data and gain insights into the weather patterns. We hope this video was informative and helpful in your data science journey. Thank you for watching.